must be greater or equal to 0, so the domain of this function must be 0 to infinity, because it's an even index. And this is very important. Important function. So here it is. What is the range of this function? Thank you, 0 to infinity. Any questions? Any questions on the graph of the square of x? What if I want to graph the square root of negative x? What transformation will that be? Which direction? I'm changing x into negative x. Yes, well done. This is the square root of negative x. What if I want to graph negative the square root of x? Yes. Now I'm reflecting with respect to the x-axis, so this is negative the square root of x. These are other transformations. Reflections, in other words. Okay. Any questions from me? Yes?
The left graph?
This one?
No, just like on the sheet.
Oh. Well, which page is that?
It's 7 as one.
Yes?
Yeah, just the left side.
This one? Oh, this is a quadratic function. We're not talking about a quadratic function. We are talking. They're asking you to select.
Oh, okay. Yeah,
Therefore, they give you 4 different graphs, and you have to select.
okay.
I'm not interested in that. I'm interested in your work. Yeah. So I didn't even look at that because not important what they came up with. Okay. So what type of function is this? Yes.
So,
Yes.
when we're trying to show work on the graphs and stuff, do you want us to like write out all the?
No. I just want you to understand what we're doing and put in the answer. That's fine. But remember, on tests and the class quizzes, you will have to show the work. Yes. Very good question. Thank you. Okay. What type of function is this? Very good. Excellent. Thank you. What is the base of the exponential function? And then I'm going to ask you what function is it. Just the base right now. No, there is no negative base. So let me refresh your memory. F of x equals a to the x. There are only 2 possibilities: a greater than 1 or a between 0 and 1. Actually, the question is why, right? Why? I mean, I can take this -3, I can raise -3 to the 2nd power, to the 4th power, to -3 power, right? How come that we don't allow 0, 1, or negative numbers in exponential? So you will never encounter, it's not possible, you'll never encounter f of x equals -3 to the x. This is not an exponential function. You will never encounter f of x equals 1 to the x. That's not an exponential function. And you will not encounter 0 to x minus 1. These are not exponential functions. The question is why? Why are these excluded? Say it again. No. Why a is restricted to be not 1, but more than 1, or not 0, not 1, but in between 0 and 1.
You raise 1 at a time, and it just stays 1.
True, but why isn't this an exponential function? There is only one reason. Log function, which is the inverse of this one, will not exist. So that's the only reason why we can't, or we have to exclude 0, 1, and negative numbers. Its inverse will not exist. You cannot put in a base of 0, 1, or a negative number in the log function. And all exponential functions are one-to-one, and they have an inverse function, and that's log. So for that reason, we had to exclude all these options. Okay, perfect. So this is an exponential function, and the base is 5. 5 is the base, or in other words, A. A is 5. Now the question is, what is the first transformation here? Well, there is only one transformation. It's negative 5 to the x. So the base function is 5 to the x, and there is only one transformation. Does anyone remember how to graph f of x equals 5 to the x? If a student asks me sometime in the middle of the semester, Professor, can I still get an A in my class? I'm not doing very well. And my answer is yes. As long as your grade from now on will follow an exponential function with a base greater than 1. It's the highest growth possible. And this is 5 to the x. You will not find a bigger growth than the exponential. So the answer is yes, as long as the grade follows this trend. Okay, now what type of transformation is this? I gave you an example here. So this is the base function, and it has a minus in front. Well, I'm not changing x. The minus does not touch x, but the minus touches the outside, which is the y value. And when the minus touches the y value, what type of reflection is that? If it touches the x, if it touches the y. Right? So it's a reflection with respect to, this is negative 5 to the x. Notice that this is not in parentheses, which means this is negative 1 multiplied by 5 to the x. It has nothing to do with the base. It's just a number outside. So I have no idea what they put in here. We don't care. Obviously, this is, I wouldn't say that this is a correct graph, because it gives you the impression that starting from negative 2, the horizontal asymptote and the graph are the same. That's not possible. So be very careful with this. Questions? Questions? Any questions here? Okay, ready to move on? Okay, the next one is what it's called. Can anyone tell us what is the next problem? What kind of function is this? Excellent. Piecewise defined function. Now, in this problem, we are only asked to find this value and that value. I'm not interested in that. I'm interested to graph it. And you will see why in this class is so important. Okay, and then we'll answer those two questions, whatever they are. First, let's identify the domain. Oops. And what I recommend is change this into interval notation and change this into interval notation. What will you say? What is the interval notation for this? Excellent. What is the interval notation for this? With parentheses, 0 to infinity. So then what is the domain? Say it again. But if it's there is no gap, it includes 0 here and it does not here. So what do we write? What is the domain of the function? Thank you very much. So because that's the case, is that clear, everyone?
Yes.
Let's create a table to get some ordered pairs and be able to graph this function. 0 is the key number or value of x. Why? Because see what happens at 0? The function changes from what type? Quadratic to
Linear.
right. So this must be a very important value. Because of the symbol of a bracket to the left, I'm going to copy it on the 0. Because of the symbol parenthesis to the right, I'm going to copy it under 0, but touching the bracket. Do not leave a space between those two symbols. I know that this is an overkill. Can anyone tell us and read for us, because these may not be in the correct order. Which function will we be using between negative infinity and 0? Only one. Which function? For x values between negative infinity and 0, we will be using,
The first
of course, 1 minus x squared, thank you. And for 0 to infinity, which function will we be using? I know it's silly. Right. Perfect. So now, 1 minus x squared, I'm going to choose negative 1, and please plug it in and tell me the answer. We agree with 0. Please plug in 0 and give me the answer. Perfect. Now, something that you will not like, I'm going to ask you to plug in 0 here. Am I allowed to ask you to do that? No, I'm not allowed to. I shouldn't, but I will ask you to. So please plug in 0. You'll see in a moment why. 1. And let's plug in another here. Let's say 1. 2 times 1 is 2 plus 1 is 3. Okay. Let's graph the function. Remember, the first branch is quadratic. The second branch is linear. From left to right, please give me the first ordered pair that we have to plot. Negative 1, 0. The second ordered pair. 0, 1. It's a full point. This is a quadratic function. X squared looks like this. Negative x squared and up 1, right? So this is the graph of the left branch. It cannot be extended to the right of 0. That's why I asked this silly question. Between negative infinity and 0, which function will you graph? And you correctly identify the graph or the function. Now, between 0 and infinity, I have a totally different function to graph. It happens that it starts at the same point. This is not always the case. And 1, 3, 1, 3. And this is it. This piece is only between 0 and infinity. This piece is only between negative infinity and 0. And this is our function f of x. And if I were to ask you what is the range of this function, you will say, exactly, negative infinity to infinity. Perfect, Michelle, thank you. Okay, so now they're asking us to find f of negative 6, and they're asking us to find f of 9. Well, of course, I already have the table. Shouldn't be that difficult. So f of negative 6 is here, so I have to plug it in this function. F of 9 is here, so I have to plug it in this function. So when you plug in negative 6, what will you get? Negative 6 squared with minus in front. Negative 36 plus 1, negative 35, which makes sense. And when I plug in 9, 2 times 9 is plus 1, 19, which makes sense. It's way more important to review how to graph than just plug in numbers, but that's fine. Okay, see if we need to look at 10 and 11. If you say no, we'll move on. If you say yes, we'll do them. Was that a yes?
Yes.
Yes? Okay, perfect. So we are given two functions. F of x equals x squared plus 3x minus 2. And g of x equals 3x minus 9. They want us to find the function g comp f of x. So this is function composition. It's not addition of functions, it's not subtraction, multiplication, division, but it's function composition. So, what does that mean?
Substituting the 3. So you would, I guess you would do 3x minus 9.
Let's write the
squared.
definition first,
Oh, okay.
because it will be easier to identify the next step.
You have to plug in.
So we write g of f of x, g of f of x, which is x squared plus 3x minus 2. And now I stop and look at g. Ask questions? Any question? Anything? Okay. So g says 3 times whatever minus 9. So 3 times whatever minus 9. Does that make sense? Yes? So let's distribute 3 and then subtract 9. So 3x squared plus 9x minus 6 minus 9, negative 15. Now, how do we call this function? And how do we call this function? Extremely important for what follows in this course. So g comp f. What is f of x called and what is g of x called?
Inner and outer.
Very good. Inner, outer. Why is f of x inner? Because it's the first function we apply to x. What is g? Why is g the outer? Because g is applied to this. So I like to present this with bubbles. They're not called bubbles. I just like to call them bubbles. So something like this. X, first f is applied to x. We get a number which is f of x. And then we apply g to get g of f of x, which is the function composition g comp f. So f is the inner because it's applied to x first. We get a number, and then we apply g to this number. That's why this is the outer and this is the inner. Because this is connected to the next question. We are given f of x, which is 5x plus x squared to the 4th. And they want us to find the inner and the outer. And I have to caution you, there is more than one correct answer here. You can find out one that works, two that work, inner, outer, and I can find out. So, look at this function and say, if I want to evaluate this for 5, what will I evaluate first? Well, this is what I have to evaluate first. And when I'm done, I'll apply that function. So this must be the inner and that must be the outer as one option. So what is the inner? Let's call it g of x. Excellent. 5x plus x squared. Now you're done. You get one number. Which function do you apply to this number? That's it. So let's call it f of x, x to the 4th. So when we are done evaluating 5x plus x squared, we get one number. We raise that number to the 4th power, meaning we are applying x to the 4th to that number. Is this okay? So this is called function decomposition. We decompose a function into other functions. Finally, simplify the difference quotient. If this were not an issue, this skills assessment and refreshing your memory, this is what I would have started with. I would have started with a difference quotient for all sorts of functions. So that's what you should expect as the next step. So the difference quotient, let's discuss a little bit, since we're here, what it means. Because what is the meaning of difference quotient? What does it mean? Can anyone say anything? Remember what a difference quotient is?
Distance between 2 points of a function.
Say it again.
The distance between 2 points of a function.
It's actually the rate of change.
Yeah.
Yeah. Okay, so let's take a look. Here's a function. And let's say we have 2 points on this function. This is point P, x comma. What is the y value? If this is 5, then what is the y value? Say it again. F of 5. If this is x, what is the y value? Very good. Of course. It's on the function. The coordinates must verify the equation of the function. Good. Now let's say we create another point here, which is very close to P. But I won't be able to explain. But imagine that it's very, very close to P. I'm zooming in other words. And because it's very close to P, I'm going to say it's x plus a little bit. And I'm going to denote the a little bit by h. Now, can anyone give us the coordinates of Q? X plus a little bit, comma, S of x plus a little bit. Indeed. Now I would like to determine the rate of change of this function between P and Q, which is the slope of this line, secant line. Rate of change. Between P and Q, which is the slope, which is called the difference quotient, which represents the rate of change of this function between P and Q. So can anyone dictate the slope of this line? And we know it's y2 minus over. Very good. So please give me the answer. Y2.
F of
Yes.
x plus h.
Very good. Minus.
F of x.
Very good. Over.
X plus h. Minus x.
Indeed. These two go away. So this is f of x plus h minus f of x divided by h. This will occupy about 75% of this course. Just this. So we have to practice by looking at different functions and determining the difference quotient. We determine in all algebra courses for different functions. But here it's when we really need it. Okay, so we are given a function which is f of x equals to the square root of x. And they say, find the difference quotient and simplify it if you can for this function. So I write again the difference quotient, and you have to memorize it moving forward. We need it. So f of x plus h minus f of x divided by h. So what do I have and what I don't have so far?
You have f of x.
Indeed. I have h because I can't do anything, it's just a little bit. But this is the only quantity that I don't have. but it's okay. I can get it. So what is f of x plus h? So remember how we read the f of x, right? F of whatever equals 2 times the square root of whatever. If this is x plus h, then what is f of x plus h? Right, 2 the square root of x plus h. That's it. That is it. But now the question is, how do I simplify this? So how do I simplify it? Yes, I would definitely do that first. I completely agree. 2, the square root of x plus h minus the square root of x divided by h. That will definitely be my first step. But now I have to rationalize the numerator. What do I multiply and divide by to rationalize the numerator? Rationalize the numerator. We multiply and divide by
Conjugate
the conjugate. Very good. X plus h plus the square root of x. And I have to multiply and divide by the same thing. This quantity is basically 1. But the type of 1 that I need, that does the job, but it's still 1. So we reviewed on the first handout the answer for this product. It's the third special product. Be very careful and tell me what I should write. Third product from our first handout tonight. Correct. So I'm going to copy the 2. I'm going to copy the h, and I'm going to copy the square root of x plus h plus the square root of x. And I'm waiting for you to multiply the 2 tops. You should not think, right? It's a plus b times a minus b. It must be a squared minus b squared. There's no thinking, right? We know the special product. So what will you tell me to write?
x plus h minus x.
That's it. First term squared minus the second term squared. When I square this, I get this. I have to copy minus. When I square this, I get that. Is this okay? Everyone? Okay, so obviously the x with negative x go away. Then I continue with 2h at the top. H, the square root of x plus h plus the square root of x. And this will always be the case with all difference quotients. All terms without h must, from the top, must go away. And then eventually, this h must simplify. There's still a left over, but you cannot do anything about that. So the simplified form is this. So let me repeat. Every time if you want me to write this down, we will write it as a note. Every time we are asked to determine and simplify the difference quotient for any function on the planet, 2 things must happen. All terms without h at the top must cancel out, otherwise we have an error somewhere. And eventually, this h from the denominator, which one? This one. Which one? This one, must go away. You cannot erase it, right? It has to go away with a factor from the top, and it does. You can still, and you will still have an h left in the problem, but it doesn't matter. You'll see what happens when you determine the limits and the derivatives. So, 2 things. Should I put this in writing? Okay. So, I lost my page number 12. Okay. Note, when simplifying the difference quotient for any function, one, all terms without h must go away from the top, from the numerator. This must happen. And number two that has to happen, h from the denominator must simplify with some h from the top. H from the denominator. Must simplify. After you factor out the h from the numerator, something, something, it must go away. For any difference quotient of any function. Any questions? Okay, would you like to factor number 13? Is that a yes or a no? So we have a factor, we have something about a polynomial. Let's see what's left. We don't care about the graph. I mean, I'm not looking at graphs when I'm graph, so. And then 15, solving a log, it's some trig, and that's about it, and the graph. Okay. Yes, I know we only have 5 minutes left, and I'll stop in 5 minutes, I promise. So we may not be able to finish. I'm sure we are not able to finish. Okay, so we continue with factoring, or factoring is okay, or you still want to see it. It's up to you. Yes? Yes? Okay. So this is a squared plus 2a, everything squared, minus 2a squared plus 2a, and minus 3. Okay, here is the method that I would apply to this. I would say, let y, or any other letter but a, be a squared plus 2a. Because I see it here, and I see it here. You can say you're changing the problem. No, I'm changing the notation or the outlook. So this is y squared minus 2y minus 3, which I have no difficulties factoring. This will take me a few seconds to factor, right? How would you factor y squared minus 2y minus 3? I agree. Y minus 3, y plus 1. And now I'm going to put this back. I'm going to put the y back in. A squared plus 2a minus 3, and a squared plus 2a plus 1. What is the other option, which I will never do? Square this, combine like terms, and get a to the 4th, and then I'll probably not know what to do with it. I haven't looked at it. I'm just saying. I don't know. Maybe. So now I will factor this, and I will factor this. And I'm done. So how do I factor the first one? We just had something similar a second ago. This time is a plus 3 and a minus 1, and what is this? So this method is called the substitution rule or substitution method, and this is very useful for later. Okay, so we use the substitution. This is not always possible. Here it was, because this quantity and this quantity are the same. Otherwise, I would not be able to just substitute for something like that, but it was much easier. Questions? So here we are given a polynomial, and this is pretty much review from pre-calculus. They want us to find the y-intercepts, describe the end behavior, determine the zeros and their multiplicities. So let's see, I know there are 2 minutes left, so let's see what we can do from this one, and then we'll continue on Wednesday. But please start working on the assessment, okay, and turn it in till this point. You don't have to do more, but till problem 13. So the first 13, please work on them. Not before you redo those problems if you have any difficulties, right? If you happen not to remember what we have seen today. So then P of x equals -3, x plus 4, and 3x minus 2 squared. So let's find the x and y-intercepts if we have time. Let's just find the y-intercept is the easiest in 1 minute that we have left. How do I find the y-intercept for any function? Very good, awesome. P of 0. So -3 times 4 multiplied by -2 squared. So finding the y-intercept is always the case. We plug in 0 for x. So then -3, 0 plus 4 is 4, 0 minus 2 is -2 squared. We have to start with the square, which gives us a 4. And then 3 times 4 is 12. 12 times 4 is 48, and there is a minus in front, and we get -48. So 0, -48 is the y-intercept.